Hi students, welcome back to the online classes. This is the second session of the chapter laws of motion. So, in the previous session we have learnt about Newton's first law of motion. What is Newton's first law of motion? Every object will likes to stay, every object continues to stay at rest or in uniform motion unless external force act on it, unless external force act on it. So, in this lesson we will discuss about Newton's second law of motion. Newton's second law of motion. So, this Newton's second law will give how the object will, what happens to the object when non-zero net force act on it. It will give what happens when, it will give, this law will give what happens when a non-zero net force acts on the object, when non-zero net force acts on the object. This law will give about a non-zero net force acts on an object. So, what happens when a non-zero net force acts on an object? That will be given by this Newton's second law of motion. What I have written here? Net force. What is meant by net force? Net force is the algebraic sum of forces, not algebraic, sorry, it is a vector sum of forces acting on the object. It is not a normal summation, it is a vector sum. Vector sum means you have to take the directions. For example, so you and your friend are applying some force on this block. So, this friend was applying force, 2 newtons of force is applying in this direction, and your friend is applying 1 newton of force in this direction. What is the total force? What is the total force acting on this object? The total force will not be 2 plus 1. It is not, it is a normal algebraic. It is not, it is a normal algebraic summation. Algebraic summation. So, the total force will not be an algebraic summation. This is wrong. The total force is not 2 plus 1. The total force, we will call this as, it is not a normal summation, that is why we will call it as net force. Net force means it is the summation only, but it is a vector summation. Vectors means you have to include the directions. So, take this direction as positive and take this direction as negative. So, it is positive x axis and this direction is negative x axis. You may know about the graphs, you may study about the graphs. So, this is positive x, this is negative x. So, like that this force is considered as minus 1 Newton and this force is considered as plus 2 Newtons. So, now take the summation. So, first force plus 2 Newtons plus minus 1 Newton. So, here what I was included, this minus sign, positive signs will denote the direction of the force. This positive and negative signs will denote the direction. Positive means towards left side, negative means towards right side. Okay. So, here positive 2n plus into minus 1 Newton, here 2 Newtons, 2 minus 1 is 1 Newton. So, this is the net force acting on this block. The net force acting on the block is 1 Newton. So, net force is nothing but the vector sum. We will call this summation as vector summation. We will call this summation as vector summation. We will call this as vector summation. Vector summation is nothing but it includes direction. We will include the directions for this physical quantity force. We will include directions for the physical quantity force. So, this is about net force. While finding the net force, you must has to include the directions. You must has to include the directions. To find the net force acting on any object, to find the net force acting on the object, you need to draw a free body diagram. You need to draw a free body diagram that we will simply call it as FBD. FBD, free body diagram means, free body diagram gives, this diagram includes, this diagram shows what are the forces acting on the object. Free body diagram This diagram will shows what are the forces acting on the object. For example, a body is at rest. A body is moving in this direction. Let us take that the body is moving in this direction with velocity v. What are the forces acting on this object? The first force is its weight in downward direction. Weight W is equal to mg. Weight W is equal to mg acting in the downward direction, and the normal force capital N acting in the upward direction. And since the object is moving in this direction, this object will experience a frictional force in the opposite direction. This is the frictional force. So, what I was drawn here, I was denoted all the forces acting on this object. How many forces? 1, 2, 3, 3 forces. All the forces acting on the object I have represented here. So, this diagram is nothing but a free body diagram. So, free body diagram will list out, will shows how many forces are acting on the object. So, for example, if any object is at rest, does that mean no forces are acting on it? For example, I have found an object, it is at rest. I have found a block at rest. This is at rest. Does that mean the forces on the object is 0? No, forces are acting on it, but the forces are balanced. What are the forces acting on this rest block? One is weight, gravitational force, and another one is normal force. There are 2 forces acting on this, but the block does not move. Why? Because the 2 forces are equal. So, the if 2 forces are acting equal, if this force is greater, it will move in this direction, this block. If this force is greater, in this direction this force is greater, the block will move in this direction. If the 2 forces are equal, the block will remain at rest. If you found any object at rest, it does not mean that there are no forces are acting on it. Forces are acting, but all the forces acting on the object are balanced, are cancelled. Here the upward force and the downward force are cancelled. So, the total force is 0, but forces are acting on the object. So, if you found any object at rest, it does not mean that the forces acting on the object are 0. Forces are acting, but the forces are balanced. If the forces are balanced, we will call this state as equilibrium state. We will call this state as equilibrium state. This is at equilibrium state. So, all the forces are balanced on this object, that is why we will call it as equilibrium state. Equilibrium state is if all the forces acting on the object are balanced, then that state is called as equilibrium state. This is at rest, forces are acting on it, but all the forces are balanced. So, let us consider another object. So, this object is moving with same velocity, let us say 30 meters per second. This object is moving with velocity 30 meters per second. What are the forces acting on it? So, here also the forces are balanced. When the object is at rest or moving with constant velocity, what does that mean? The forces are balanced. All the forces are balanced on this object. If there is forces acting on the object, if the forces are acting on its speed increases or its direction changes, but here the speed is same. The speed is not neither decreasing nor increasing. What does that mean? Here also, if the object is at rest or in uniform motion, same speed means uniform motion, it means that no forces are acting on it. It means that no forces are acting on it. Let us look what happens when a non-zero force acts on it. When the object is at rest or when the object is in uniform motion, what is the total force acting on it? The net force is 0 if it is at rest, or if it is moving with same velocity, the net force is 0. So, keep that point in your mind, and before getting into the Newton's second law of motion, we need to know about momentum. 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 So, momentum is defined as momentum is defined as the product of mass and velocity. Momentum is defined as the product of mass and velocity. Momentum is denoted with P. P is equal to m into v. Very, very important. P is equal to m into v. So, here you know that v is the velocity, rate of change of displacement, and m is the mass, it gives the quantity of the substance. So, here what the momentum gives. So, for example, your friend has dropped a stone from certain height, he was at the third stair, he was in a building and he was at the third stair. So, he was standing here and dropped a small stone and a larger stone. He has dropped two stones. Initially, he has dropped a small stone and you need to catch that, and you need to catch that. So, he was dropping the two stones from the same height, but which is difficult? For example, or so not like this. Let us consider another example. So, your friend has thrown two stones to you. There is some quarrel between you and your friend has thrown a stone towards you. He has thrown two stones, one is smaller and another one is larger. But he has thrown with same velocity. So, the small stone with thrown with 20 meters per second speed and the larger stone is also 20 meters per second speed. So, which one will hurt you a lot? The larger one. Why? Because it is having large mass. If he has thrown with so here how can you know that this larger mass of stone impact you a lot? Why? Because here the mass is greater, of course the velocities are same, the mass is greater. So, similarly the momentum will give how much mass was attached with this object. Mass in motion, that is why Newton will call this momentum as mass in motion. Mass in motion. How much mass was in motion? For example, if I say an object is moving with 20 meters per second, an object will move with 20 meters per second. Does this include any mass? No. If you specify the momentum, that momentum value is 30 kg meter per second. So, this includes the mass also. How much mass was associated with that speed? 20 meters per second. How much mass was associated with that speed? So, this momentum will give how much mass was attached to the velocity of the object, how much mass was given, how much mass was associated with that velocity. It will include, the momentum will include both mass, both quantity and speed also. It will include both quantity and speed also. So, that is why momentum will be also called as, not also called as, Newton will say that momentum is a mass in motion. Momentum will give how much mass was in motion. If you only know the speed, did this include any mass? No. If you know the mass, if you know the momentum will include both mass and velocity of the object. Momentum will give how much mass is in the motion, how much mass is associated with that motion. How much mass was? If lorry and car was moving with same velocity, which will have more momentum? They are having same velocity, but the lorry mass is having greater, that is why the momentum of the lorry is very much greater. So, here momentum will give how much mass was associated, how much mass was attached with the velocity, how much mass was attached to the velocity, how much mass was attached to the motion, like that. So, momentum is defined as the product of mass and velocity. And now, let us state the Newton's second law of motion. So, according to Newton's second law of motion, according to Newton's second law of motion, the net force acting on the object, the net force acting on the object is equal to the rate of change of momentum. Rate of change of momentum. He has given that F net is equal to, he has given F net is equal to delta P by delta T. F net is equal to delta P by delta T. How fast the momentum will increasing? So, what will the net force will do? Net force will increase the momentum, net force will change the momentum. Rate of change of momentum, in 1 second how much momentum was increased. So, this that will be equal to the net force acting on the object. F net is equal to delta P by delta T according to Newton's second law of motion. If you apply some force, for example, an object is there, the mass of the object is 10 grams and the velocity is 20 meters per second. If you apply the speed, if you apply the force, what it will change? It will change the momentum. Here the product of the two is 200. If you apply the force, what will happen? It will change the momentum. If you apply the force, the velocity becomes 30 meters per second and mass is equal to 10. Then 10 into 30, 300. The product of mass into momentum is nothing but, the product of mass into velocity is nothing but momentum. So, here what is the momentum? 300. Here what is the momentum? 200. Why this momentum change was occurred? Because of the force. What a force can do is, it can change the velocity, it can change the momentum, that is it was given in the equation form. F net is equal to delta P by delta T, rate of change of, we will call this as rate of change of momentum, rate of change of momentum or rate of momentum, rate of change of momentum. According to Newton's second law, the net force acting on the object is equal to the rate of change of momentum. So, let us obtain another equation form of Newton's second law of motion. So, according to Newton's second law of motion, F net is equal to delta P by delta T. F net is equal to delta P by delta T. What is P? P is the momentum. So, in the place of P you can write P is equal to mv. P is equal to mv. So, substitute mv in the place of P. F net is equal to delta into delta T into mv. Here delta by delta T, since the mass does not changes with time. If any object is in motion, the object mass does not changes. So, you can write it outside, So, m into delta V by delta T, m into delta V by delta T. So, here what is delta V by delta T? So, delta V by delta T is nothing but acceleration. Acceleration A is equal to delta V by delta T. So, you can substitute acceleration in the place of delta V by delta T. So, F is equal to m A. This is another form. This is the initial first form and this is the another form of Newton's second law of motion. We will call this equation as equation of motion. Equation of motion. So, what it was giving? If a net force act on the object, it will accelerate. It will accelerate the object. The net force acting on the object will accelerate the object. Accelerate means it will increase the speed. The speed of the object will be increases. If a force acts on the object will be accelerated. Accelerated means it may be increase of velocity or decrease of velocity. If you apply force in the same direction of motion, the velocity of the object increases. A ball is rolling in this direction. This is called direction of motion. If you apply the force in the same direction only, what will happen? The velocity of the object will be increases. The velocity of the ball increases. So, here what is happening? Your force, the applied force is used for accelerating. The applied force is used for accelerating. Accelerating means increasing of speed. The applied force is increasing the speed. So, that is why F net, you have got F net is equal to m a, F net is equal to m a. So, let us consider two objects, and the mass of this object is 10 kgs and another one mass is 20 kgs. So, let us say that if you apply 2 newtons of force, if you apply, how much force is applied on the two objects, you have applied 2 newtons of force. Let us say if you have applied 20 newtons of force on these two objects, you have applied 20 newtons of force on this object, and this smaller object will accelerate, 2 meters per second square. So, the speed of the object will increase 2 meters per second in 1 second. So, this is the acceleration. How much acceleration it got? 2, whereas this object will accelerate 1 meter per second square. You have applied 20 newtons of force. So, here 20 into 1, mass into acceleration is equal to force, mass into acceleration is equal to force. Here mass into acceleration A, 10 into 2 is 20. So, here if mass is low, it will accelerate more. If mass is high, it will accelerate less. So, in this way the mass and acceleration will balance, will be equal to the product of mass and acceleration will be equal to the net force acting on the object, Now, let us learn about Atwood mission. So, what is Newton's second law? The Newton's second law is F net is equal to m a. Just keep this equation in your mind. F net is equal to m a. So, let us learn about Atwood's mission. So, Atwood mission is an arrangement that verifies Newton's second law, that verifies this equation, with the Atwood mission. Atwood mission is used to verify Newton's second law. It will use it to verify Newton's second law in the laboratory techniques. In the laboratory, we can verify Newton's second law with this Atwood mission. So, Atwood mission consists of a pulley. The Atwood mission consists of a pulley and two masses are connected. Two masses will be connected through a string. So, this is m2, let us say this mass as m2 and another mass m1. So, here two masses m1 and m2 are connected with a string through and placed through a pulley. So, here let us say the m1 is greater than m2. Let us say that m1 is greater than m2. So, this is larger mass when compared with m2, this is larger mass. So, this is larger. Since the m1 is larger, what will be the direction of motion? It will move in this direction. M1 will move, m1 will accelerate in this direction and m2 will accelerate in this direction. So, let us find out these accelerations. So, from the to apply Newton's second law for this mass m2, F net is equal to m a, you need to draw a free body diagram for this m2. So, let us draw a free body diagram. Free body diagram means you have to list out the forces acting on this. So, this is mass m2, its weight acting in the downward direction m2g. m2g is the m2 into g, mass into z will give the weight of this object. Mass into g will give the weight of this object, and since it is connected through a string, a tension force T acts along the string. A force along the string will act. So, what that force is called as tension T, and the object is accelerating in this direction. So, what are the forces? M2G and T. So, the downward direction will be taken as negative and the upward direction is taken as positive. So, F net we has to apply Newton's second law. F net is equal to M2 into A. I was applying this law for this mass 2, for the second mass. That is why in the place of M I have written M2A. So, F net, what is the net force? Positive T minus M2G is equal to M2A. So, let us say this equation as 1, and similarly apply Newton's second law of motion for this M1. So, to draw a free body diagram for M1. Free body diagram for M1. So, the free body diagram of M1. So, M1, the weight M1 into G acting in the downward direction, and the tension T. Tension will always act away from the object. Tension will always act away from the object. So, this is the tension T and it is accelerating in the downward direction. So, now apply Newton's second law for M1. Apply Newton's second law for M1. So, F net is equal to M1A. F net is equal to M1A, but minus M1A. Why? Because the acceleration is downwards, minus M1A. Now, F net, what will be the F net? So, upward T minus M1G. T is upward direction, that is why I have placed plus T. This is downward direction, minus M1G is equal to minus M1A. Multiply this total equation with minus. So, if you multiply the total equation with minus, here I have doesn't denote any sign. What does that mean? Here there is plus sign. Since it is plus, I was denoted, I doesn't denote any sign. So, multiply the complete equation with minus into plus, minus T, minus into minus, plus M1G is equal to, we are multiplying the total equation with minus. So, minus into minus M1A. So, this is equation 2. This is equation 2. So, what is the first equation? T minus M2G is equal to M2A, and minus T plus M1G is equal to M1A. So, these are the two equations. Let us add these two equations. Add. So, plus T minus T gets cancelled, and what will remains here? Minus M2G plus M1G is equal to M2A plus M1A. I have add equation 1 and 2. Add equation 1 and 2. So, here you have found G as common. Take G as common. Take G as common. So, what will remains here? Minus M2 plus M1. So, you can write this as M1 minus M2. M1 minus M2 is equal to, A is common here. So, if you take A as common, what will remains here? M2 plus M1. You have taken A as common. So, we want to, what is our target? To find the acceleration. So, acceleration A is equal to, so bring this M2 plus M1 to this side. Here this term M1 plus M2 is multiplying. If you bring this term to the left hand side then what it will becomes? It will comes under denominator, G into M1 minus M2 by M1 plus M2. This is the acceleration of the two masses M1 and M2. So, with this equation you can verify this Newton's second law of motion. So, with this we have completed about Newton's second law of motion. In the next class we will discuss Newton's third law. Thank you.